Hello, how's it going? This one's a little more casual. So what I want to look at is basically drawing sprites quickly. Like, how quickly can we do it? How many sprites can we draw? Are there any tricks we can use? And this will be sort of impromptu, off the cuff. As you can see here, I'm not doing it in the normal way. That's okay. And I'm going to be live coding this, so sort of sit down, grab a coffee. We'll be in for the long run. So if I switch over here, I've got Visual Studio Code open. I did do one bit ahead of time because it was just tedious, and that was hard coding in all these file names. So I wanted to go through an example of drawing a whole bunch of sprites. We can see here, I just went on Open Game Art and got a collection. Some of these seem to be the same image, but a lot of them seem to be the same image, but I'm just going to randomly select a bunch of these images and place them at random positions on the screen and see how many of those we can handle. So first thing I'll do is my imports. So I'll import pygame, and I'm also going to import numpy. And the reason I'm going to import numpy, I'm not doing anything serious, but I just want to choose some random positions and some random sprites, basically. So let's see, we'll go initialize pygame, and then we'll create a screen. For the size, I reckon, so I want to display the frame rate up in the caption of the screen. So I could go full screen, but I'm not. I'm just going to go a little smaller than full screen. So 1280 by 800, I reckon, is reasonably big. I've got a bunch of these flags, and I've heard that although we used to, in the past, be able to specify a hardware surface beyond pygame 2, it's actually already a hardware surface, so we don't need that flag. I'm also going to make a clock in order to track my frame rate. Okay, so I'll set up my basic loop. We'll go done. I'm just going to detect a an escape key. So I'll say if we have key down and the key is escape, then we'll quit. I'll just make this a little bigger. Okay, that'll make us quit. I'll also go ahead and fill the screen with some color. In this case, I guess some sort of dark teal color, and I'll update the display. Then I'll do my timing stuff, so I'll say frame rate, and then I will go ahead and set the display of the caption. So set the caption, something like that. Okay, so this is just clearing the screen. This is not drawing anything. I just want to get a baseline. Of course, I need to update the clock. Okay. Now that's very interesting. 100, almost 200 frames per second. I wonder if OBS is messing with that. I also wonder whether updating or flipping has a different effect. It has much the same effect. Okay, right, so let's take that as a baseline. So, not entirely sure why it's super slow, but that's what we're working with. When I did this sort of off camera myself for fun, I was getting about 400 frames per second. But hey, that's the situation. So the next thing I'm going to need to do is I'm going to need to load images, and then I'll say I'll say create sprites, but I'm not really going to create sprites. I'm going to just do it completely naively. But we do need to load the images. So I'm going to define a dictionary where the keys of the dictionary are going to be these image names, these strings we see up above, and the values of the dictionary are going to be the images that we've loaded, the underlying image resources. So I'll say for, I'll go for code in image names. Go pygame image load, and we'll put in the file name. So I'll need to construct the file name. And if I look in here, I've got sprites like that. And like I said, I'm doing this fully naively, so you're probably jumping out and saying, convert the surface. We'll get to that. I'm just going to do this fully naively. Okay, so I'll go image count. We'll start with 10. We'll see how we go with 10 images. Here we go. Going to need to generate a few things. I'm going to need the X and Y coordinates of the image, and I'm also going to need some sort of integer which indicates like which of these we're going to use. So we'll start with the X. Go numpy random randint, and we know that this needs to be between 0 and 1280, just for our example. And likewise, we'll go 0 to 800. Okay, cool. And we're just randomly choosing a position from within this array. Okay, so now I'm going to look in there, go image, that. That will get me the image object, and then I'm going to need the rectangle. So say image. Sometimes this auto-completes, sometimes it doesn't. I can give it a little hint here and say, okay, I'm getting that. I expect it to be a pygame surface. Okay, so I've got that. And now what I'm going to do is I'm going to move it by X and Y, and that will give me a copy of the original rectangle which has been moved. And that's pretty much the info that I need, so I can then get my objects and append all that info. Okay, so that has built up the set of these tuples with the surface that we're going to blit onto our screen and the rectangle describing basically where we're going to blit it. Now down here we can go ahead and we can look through all of that. So I can say for object in objects, then I can unpack it and I can say I'll go source, surface and destination rectangle, unpack it into its elements, and then we can directly blit that. So we can say screen blit. So for our source, that's the source surface. For our destination, that's the destination rectangle. And I don't think we need to specify anything else. I think that should be fine. Okay, so let's give that a go and see how it's going. Okay, so frame rate is not doing too well. There are a few things. Also, the images are way too big. There's that too. So let's address those issues. First up, I reckon we can probably convert the surface, and that might speed things up. Go convert alpha. See what that does. Cannot convert without pygame display initialized. Yeah, okay. So the way this works is pygame display. The purpose of converting is to get the surface into the same pixel format as the display, and we can't do that until the display has really been created. Okay, so that has made things significantly faster, and now I'm going to deal with the issue of the images being way too big. So I think I found originally that if I made them 1/10 the size, it worked pretty well. So I'll construct this raw image, and then I'll get a copy of that. So I'll go transform scale, with a size. Ooh, okay, so I'll need to get size. So what I'll do is I'll make a raw rectangle. Just like that. And then the raw rectangle width, make it 1/10, round it up or down, and I'll do the same thing for the height. Okay. So I've loaded everything up, and now that's looking good. I can see 1, 2, 3, 4, 5, 6, 7, 8. 10's the same as 8, right? Anyway, they're there, and the frame rate looks okay. So let's start pushing that frame rate up and see how high we can go. Let's make 100 images. Okay. 80, 90 frames per second. That's looking pretty good. Let's double it. Let's go 200. I just want to get a baseline measurement. Okay, 200, we're below 60 frames per second, so let's drop it back a little. This is a lot of fun. 150. Okay, we can probably go a little higher than 150. $175. Yeah. Okay. So that's just under 60 frames per second. So, using the fully naive method, we're just under 60 frames per second. Can we do better? And the answer is sort of. Yeah. I use Pygame Community Edition, by the way. I use Linux, Fedora, by the way. Okay. Right, so surface. We've got this split function, and this split function will just do one surface at a time. We've also got this blitz function. So this blitz function will take a sequence of info, pretty much like, the sequence of info that I've got here. There we go. Okay, so let me try to apply the blitz function. Because it turns out I've already saved those objects in the data format which is preferred. Go ahead and run that. And as you can see, and this is very strange, I was very sort of taken aback by this, because I've gotten that, that Python for loop that ran 175 times. I've replaced it with a single function call, but it has not had any effect really on the frame rate, which is very surprising. Okay, so to the best of my knowledge, this is the situation. Originally I had Pygame Community Edition installed, and then after I did this, I played around with some other GPU accelerated extensions for Pygame, and as a dependency they installed vanilla Pygame. I've then just gone back and completely uninstalled Pygame, but that hasn't updated. I then tried to reinstall Pygame CE, but that hasn't really reinstalled it. It just used a cached version, and I think it didn't set up the lookup path, because both Pygame and Pygame CE confusingly name themselves the same way. So I've just got this up. I'm going to try pip install. And just for good measure, I'm going to do that as non-pseudo as well. Okay, let's give it a shot. If this doesn't work, I really don't know. Okay. Okay, right. So, using the fblitz function, we're getting significantly better performance, 80 frames per second. Pretty happy with that. This is all well and good, but I feel like we should be able to do better, right? All we're doing is copying stuff to the screen. So I had a look at this, and there's one package that I really like called Arcade. And if we look at the, let's go, yeah, look at a really simple example. I like this code style. I like the interface. We have a class which inherits from or extends the main window, and then we have sort of fixed places where we insert our code. And this seems to me like it should be better. And as a matter of fact, we look up here, Arcade versus Pygame comparison. So you can see here that under the hood, Arcade is using OpenGL, whereas Pygame is using SDL. And I know that SDL runs with OpenGL as well, but if we look at this comparison, as the sprite count goes up, it seems like Pygame suffers. Anyway, I'll get into this in a second, but it seems like Arcade is fine and Pygame suffers. So that's probably worth looking into. So I'm going to just look at this tutorial, try to adapt to this style. So I went ahead and pip installed this ahead of time. Just go import Arcade. Just looking through, this stuff is probably fine. Okay, we'll go. So we'll initialize the superclass, which is the window, and this is where we'll give it our size. So I'm going to go again with 1280 for the size, 800 for the height. Title's probably fine. Okay, now this option here, it says update rate. This is a little confusing because I tried to set the update rate as fast as I could, but that is not the refresh rate. That's not the draw rate. That's actually the rate at which this onUpdate function gets called. So for the update rate, I'm actually going to set that to 1. It's going to update as infrequently as possible. GL version, I'm going to set to, yeah, I'll go 4.5. That should give the engine enough opportunity to do like instanced rendering or whatever. I know that instanced rendering is not necessarily 4.5, but I'm just going to give it as much opportunity for optimization as possible. So what do we have here? All right. Full set amount visible. Probably background color. Should probably set that. Okay, and I think there are ways to do an FPS timer properly, but I'm just going to do it quickly for now. Okay, so I think that's all good. Then I'll go to this setup function, and this will be where I'll load all my resources. This one is insisting that we can load images directly and apply scaling at the drawing stage. So I'm going to take them at their word. We'll see how that goes. I'll go load texture, and I'll put in the file name. Here we go. Okay. Alrighty, cool. So I've got this sort of sprite list, which operates a little similarly to a sprite group in pygame, which, by the way, I did try this example with sprite groups. It's not faster. And anyway, so I'll go ahead, I'll construct a sprite. And I'm going to need to set a few things. Going to set, I guess, scale. Okay, so we'll set scale. It's 0.1. Center X. Get all this stuff up here. And now here we can see we have a file name, but loading an individual file for each of these things would be massively wasteful. But we also have a texture option. So I'll say texture and put in that image. and then we can append the sprite into that group. Okay, so we've loaded our resources. Next thing we're going to need to do is have the draw function, and I'm actually just going to, again, just clear the screen and nothing else. I'm also going to, just for measurement, going to increase my number of frames rendered. So we've got all of that. Then update. There we go. Cool. So there we've got our draw and update, and then, as you can see down here, we capture the main point of entry, and then we jump in and make this thing. So let's go ahead. Okay, cool. So we're waiting. The first time I did this, I wondered if the thing was broken. Oh, in my case it is broken, but that's my bad. That should be the instance variable. But yeah, no, for real. When I did this the first time, I thought, is this broken? I'm sorry, is this the high performance that I was expecting? I don't get it. There we go. We've got a frame rate. Oh! Am I missing something? Yeah, no, my counter isn't working properly. Okay, let me redo that. Oh my goodness. Try that again. Okay, so if I look at this, it seems to be capping the frame rate at 60, which is fine. A lot of windowing libraries will do that. But then I guess the test will be, okay, we should be able to create a bunch of sprites and the frame rate shouldn't suffer too badly, right? So then the question is, how many sprites can we draw before this really starts tanking the frame rate? So what I'll do is I'll go ahead, and I've got this sprite group. Should probably save that. Should probably save this as well, just to be sure. Never know what it's doing under the hood. Okay, so then we come in, we clear the screen, and then we draw that sprite list. And we wait, and we wait. Okay, so it's gone down to 32 frames per second. So not to get too sassy, okay, not to get up on my high horse about this, but if you're going to make a package and say that it goes way faster than pygame, and you're going to make a graph like this, I don't understand how this program is getting even close to 2,000 sprites. If I'm drawing 175 sprites and it's going down to 33 frames per second, and we could argue that, oh, there's a delta time here that I'm not using, but time is time, right? If I take the system time, it doesn't matter what the internals are saying. I don't understand. Is there something I'm missing? In one of my previous videos, somebody said that I remind them of a young Jonathan Blow. So not to get too Jonathan Blow about this, but it almost does make me want to go and implement my own library. Because I really like the interface here, and I really like this whole like F-blitz thing. But what we need, okay, is we need a more rigid version of F-blitz where it's not a fully general, I don't know. See, I don't know. A few things come to mind. First of all, there should be a more rigid version where we say, okay, I'm going to draw this sprite, and it's just a single sprite, so it's the same sprite but just at a bunch of different positions. And but failing that, I mean, it shouldn't be too hard to set up an OpenGL context under the hood and do like instanced rendering with some, possibly with some culling, I don't know. But I just feel like this is there's some sort of overhead somewhere that I just don't. And if you're going to make a library, and I don't know, I mean, I went through the example that they gave. I transcribed the example that they gave as like, this is fast, and it's not fast. And I really am about to jump in the deep end and just make my own OpenGL renderer with a pygame-like or an arcade-like interface. So I feel like I could do it better. But anyway, so this has been a little bit of an investigation into drawing things quickly. Remember I said that we would have mixed results. Yeah, mixed results. Some things are fast, some things are slow. Everything is slower than it should be, and that's life. So, all the best, and I hope to see you again soon. Bye. Hi everybody, I just want to take a second to say thank you to what's going on here? It's pretty cool. To say thank you to my channel supporters. Listen, I'm community funded. If you want to support me, it's $2.50 a month. That's about the amount of value I think these videos bring. They're pretty cool. If you do not want to financially support, that is totally fine. None of it is expected. The best thing you can do is get involved, comment, let me know what sort of stuff you'd like to see, and if there are any improvements that I can make, because sometimes I get busy with life, but I am trying to make the best content, the best educational content that I can. So, very big thank you to Antonin Caret, Declan, Endelon Studios, Isaiah Meyer, Jason Coleman, Matthew Derick, Moim, Shreyar, Skibbity Pop, and Maxim Shukim. Thank you so much, my dudes. I really do appreciate it. Hope you have a great day, and I will see you again soon. Bye.